Hi, welcome to another fast and simple development video. Today we're going to talk a little bit about MongoDB. We're going to go over the basics of MongoDB and show how to use some simple NoSQL document databases. I'm not going to go over how to install the server or set it up. I'm going to focus on the NoSQL interfaces you can use. I typically focus on Java and use MongoDB for microservices. When I use it in Java, I use the Maven plugin specifically from org.mongodb. Most of my development has been a Spring Boot, and they have a nice setup for Mongo using the JPA and Mongo template. It fits in with most of my need. Rarely do I need to go into anything lower for the Java driver. I have MongoDB installed locally on my Mac computer. This provides all the resources I normally need for development. When I need something larger, I use a free Mongo Atlas account. This lets me have an external database. It lets me use a larger data set when needed. For production, I used a MongoDB cluster, normally in Amazon AWS, sometimes actually using the NoSQL database from Amazon. This is a MongoDB compatible database, but it has some limitations, specifically on Geo Queries. I find that MongoDB has the fastest Geo query compared to other databases and has great features for finding one location or a list of locations near a Geo Lat and Long point. The 2D sphere index has been around for many years, and I've used this on many solutions. Think of finding the nearest ATM to your current location. This makes a super fast API call when needed with limited code. For 99% of all my development, I use a tool, Robo-Mongo, which has now been renamed to Studio 3D. This is a free tool that also has a paid version that gives you a few features, but for development, I find the free tool works well for me. Let's start with the basics. MongoDB has a concept of a database. We will create a database in the UI tool. Once we have the database, most of our work is done. But wait, how can that be? Well, MongoDB allows us to create a collection dynamically. Collections are similar to tables in an SQL database. Collections contain your document. This is what a document database is. What does this mean? Well, you don't have to store rows and columns like an SQL database, but you actually store JSON documents as a collections. The documents do not have to be the same type for each collection. They can actually be different. So this gets away from the traditional database system. Data is stored in a very JSON format. It's called BSON, which is a binary JSON. Each document has a unique ID. This is referenced as the _ID in the database and is type object ID. So we don't have to create this object ID. It is created on the insert of the document. So let's dive in. Let's open up Studio 3D, previously called Robo-Mongo. From here, we can create a new connection. Let's go ahead and create a new connection. I'm going to select manually configure by connection settings. I'm going to call this localhost. And it has already set up the server for the localhost and the port. So let's just go ahead and say save. I will then go ahead and select connect. And it has now connected up to my local instance. So now that I have a local instance up and running, I can go through and create a new database. So I'm going to say add a database. So I'm going to call this Mongo Fast and Simple. I normally like to have my database names all lowercase, and I'll put underscores in there. So I can now open up this database and I can see I have no collections. Let's go ahead and select this database and then open an interactive shell. So I can then go through and run queries on here. One of the things I can do is I can select the database dot a collection name, and I'm going to create a collection name. So in this case, I'm going to call it widgets. I normally use plurals for collection names. In this case, I'm going to use the insert command. And I'm going to insert a document. So a document is literally a JSON document. So let's give the widget a name. Widget 1. And let's give it a type. Type A. And you notice I'm actually entering a JSON document here. Now let's give it a location. And I'll say on the floor. All right. So I can actually click the play button to insert this. And as a result, it came up and said, right result, inserted 1. If I go over here and I right click on this database and I go to refresh, selected item, I can now see I have a collections in here. And if I expand that, I can see I can have a widgets collection. By simply double clicking that, I can now have it do a find request for the widgets. I'll hit the play button, and this will go through and find all the widgets in the database. So I created one, and we can now see the ID, _ID that it created. I can also view this as a document. I right-clicked on it and view as a document, and this is the JSON document. And so it's exactly what we added, but it has the ID in here. So our next step is to add another document. So let's go back to the previous one that we had. Let's enter a widget 2, and let's call this a type B. And the location of this is on the shelf. So let's add him. Let's add a widget 3, and he can be a type B, and he's on the shelf as well. Great. So if we go back to our find request, we can search, and now we see all the different items in here. And I have various views. I have a table view. I also have a JSON view. The JSON view will show me exactly what it looks like. And I have a tree view. In the tree view, I can click on it to expand and see all the different elements within that. So now that we know we have this first information, how does the find work? Well, the find has two methods. There's a find one and a find passing in a query. So for now, let's just pass in a query. In this case, let's look for items with location, and let's find all of them that are on the shelf. So in the system, we have 1 on the floor and 2 on the shelf. When we run this, we will see that we'll get the 2 that were on the shelf. So we can quickly find various items based on a name in the query. Now, what if we find multiple items such as this, but we only want 1? We can actually add a limit in here and specify a number. And so in this case, now I'm limiting the results to 1, and 1 comes back. I can also add a sort in here. And the sort takes a JSON object, and you specify the field name you want to sort on. In this case, I will say the location. And then a second attribute for each item, and this is where it's ascending or descending. So I'm going to go ahead and sort here, and that's how we can sort on things. So let's say we set our limit to 10, which should return all the items. And now we can see all the information still sorted. We have other options we can do with MongoDB. We've went over insert and find. There's also a couple of other options specifically for update. I can update a record, And rather than insert, I'm going to use update. Now update requires a query as well as update options. So with the update, I'm going to need to have some information in here. So for widget 3, I'm going to update it to be on the floor. But I can't just update that for widget 3. I actually need to add widget 3's object ID. So let's view this. Let's get his object ID. Now let's go back to our update. And now for the query, I'm going to specify the object ID. And let's see if we can update widget 3 to floor. As a result, 1 was matched and 1 was modified. So now if we go back and query this again, we'll see that current location is on the shelf. And when we run this query again, it does not come up because we asked for a location on the shelf. If we take our location and change it to floor, it now comes up because 3 is now on the floor. So that's how we can do an update. Well, notice on this update, we actually filled in all the fields. One of the great benefits of MongoDB is you don't need to do that. So if I go through and if I do this update here now, and I only specify floor, let's see what happens. We went through and we updated it as we expected. But when I refresh this, notice all the fields are gone. I've lost all the fields that I had. That's not what I want. So you have to be careful using an update. When all you want to do is update one parameter, in MongoDB, if I only want to update one attribute on the list, I can use what's called a set. So let me define set in here. And the set, I will define the list of items to be included in that set. So I've said do an update to this item, item number 3. I went back and updated it as it should be. So it has all the fields in here. Now I'm going to go back and I'm going to update this. I'm going to call it floor 2. Let's go through and let's search for floor 2 and see what that looks like now. So we quickly see that I did not wipe out the other items. So now I've gone through and using set, I've only updated the attributes I want. So we also have the concept of save that we can use instead of update. And if I do a save with a object ID, so we're saving the object ID, the name, the type, and the location. So this is the same as an insert, but we've included an object ID. And if we now run this, we'll say this is matched and it's been updated. But if I do this save without an object ID, we'll see it comes back as inserted. So if I come back over here, we do our query for floor, we'll see that we have an additional item for widget 3. So this isn't what we want. We actually want to delete that. So what we can do is we can just specify the ID. Let's go through and view the document again. We're going to get the ID. We're going to remove based on that document ID. And we can see one record was removed. So let's go back over here. The last record, the 1C2. Now we only have the one widget 3. So we've seen how to insert, how to update, how to save with the object ID or the underscore ID, how to save without. So if you save without, that is in fact an insert. And we've seen how to delete. That's the basis of MongoDB. But there's one other feature that I think is so important that we should go over. Let's go back to our update context. Let's go through an update. This time, instead of widgets, let's call it counts. And I'm going to insert this value right here, and I call it name widget counts. Okay. And I'm going to give it a count value of 0. Let's go through and let's insert this. If I come over here to the database and I refresh this again, I'll see I have a new table in here called counts. And if I right click or double click on that, it'll open up a find for it. And if I execute that find, here we are. We have the values and the count is 0. Typically in a relational database, there's a couple things that you can do to update a value such as count. You can read the value of the current one, add one to it, and write it back to the database. The problem in a traditional relational database is you're going to need to lock the record. Otherwise, if you have two people updating the count, and one gets a value of 0 and he increments it 1, someone else gets a value of 0 and they increment it by 1, then they increment it by 1, then they increment it by 1. He writes a value of 3. The original person writes it. Now it's reset to 1. So to avoid that, you have to do record locking. That adds a significant amount of overhead. So one of the purposes of MongoDB was to be able to allow various things to be updated very, very quickly, specifically this count system with a asynchronous operation, and that's part of the increment operator. So I'm going to go in here now, and I'm going to do an update, and I'm going to use widget counts as the name, and for the function of it, for the parameters of it, I'm going to use the increment operator. And he's going to say to do something. Specifically, I'm going to increment count by 1. Now let's run that and see what happens. Okay, let's go back over here and look at the value of count. Count is now 1. Let's run this 5 times. 1, 2, 3, 4, 5. Our value is now 6. So through this, we did not have to read the value. We did not have to worry about it. It generates eventual consistency. So the count value eventually has all of these increment pipelined and gets reflected in the database. Very powerful. If you're doing analytics, this is what you need. You can't afford to read from the database, lock it, and then update it. The other amazing thing in the MongoDB is the Geo Queries. Now let's go create another collection called products. In this products, I'm going to insert something, and as I insert it, I'm going to give it a name. blue thing. It's a good name. And I'm going to give it a location. In this location, I'm going to have an array. And in this array, I'm going to give it a latitude and a longitude. So this is somewhere near San Francisco. And I can now update this, which will then insert it. If I refresh my collections, I can open up my products and find it. And then I can see in here that I have locations as a two-item array. Let's go through and create another item. And let's create a green thing. Now let's create the green thing a little bit different location. And let's create a red thing. Again, at a different location. So now if we go through here and do a find on products, we see the various products at different geolocations. Let's open up another window. And this actually uses the Mongo Shell to power and back of it. Let's do a search using that field. So if I go through and I specify a search for this, and let's look for longitude 121 and latitude 38, and find all locations within 1,000 meters. We get an error here. Specifically, we're getting a geo near query error. To support Geo Queries, we need a Geo Index. And that's fairly simple to create. So we can say, so I'm going to open up another query window. And I'm going to say db.products.createIndex. And we have this two-element array here called location. I'm going to say location 2D. And let's see if we can create this index. Okay, index is now created. And if we look at our products over here and refresh this, we can now see we have a location 2D index. So let's go over here now and let's try to run this query again. Now we have locations. So by simply creating the 2D index and by searching on longitude and latitude, we can find matches. So I can quickly see in here that most of these locations are further away, but we have 10,000 meters. What if we simply put 1 meter? We only get back one location. What about 10 meters? We get back all three. What about 5 meters? About 2 meters. Now we're only getting back 2 results. 3 meters. We get back all 3. So by doing a find using the location in the near, we can specify the location of what we want, maybe our current location, and how far distance we want to go out. And again, that's in meters. There you go, a little bit of MongoDB. Hopefully that gives you an idea what you can do with a document database. Again, we can store different types of documents in a specific collection? We typically don't, but we could. So think about a union for a database. All right, please take a look at our other YouTube videos, our Udemy classes, follow us on Medium, and hope you enjoy what we presented. If you have any questions, leave it in the comments. If you'd like to see other things on videos, please feel free to suggest. Thank you.